Hi, welcome to today's video about massive stars that are bigger than the Sun. This is a nice animation of the system VFTS 352. It's a contact binary of O-type stars in the Tarantula Nebula, which is located in the Large Magellanic Cloud. It's 160,000 light years. The Large Magellanic Cloud is a satellite galaxy of our Milky Way galaxy. Each of these stars has a mass of 29 solar masses. They are each 7 times bigger than the Sun. They have a luminosity of 180,000 and 150,000 times that of the Sun. Their surface temperature is more than 40,000 Kelvin. Sun's surface temperature is 5,800 Kelvin. And the age of the system is just 1 million years. This is a spectral classification of the main sequence stars. The 3 at the right are the most common stars, with the M stars being the most common with 75%. 5% are the K stars. Unlike G stars are just 8% of all stars. So these 4 bigger types of stars are very rare. There's this simple mnemonic to memorize the star types. Oh, be a fine girl, kiss me. The main sequence lifetime of the most massive stars in the order of millions of years. So this was very important for life because after the Big Bang, the metallicity was very low. Metallicity for an astronomer is every element that's other than hydrogen and helium. For an astronomer is a metal. But these big stars with the short lifetime quickly increased the metallicity within the first 2 billion years. This was one very important requirement for life. And some scientists even think that during these extreme conditions in a massive star, there could be potential for the synthesis of isotopes with a atomic mass of over 260. This would mean the synthesis of unknown heavy elements that are not known yet in the periodic table. This is an example for a massive star right in our neighborhood. That's the star Sirius A, the dog star. It's an A-type star at 8.6 light years distance. It has double the mass of the Sun. This is Sirius A, this big star. It has 25 times as luminous as the Sun. It has a companion, a white dwarf, Sirius B, with 1 solar mass. They orbit each other at a distance from 8 to 32 astronomical units. 1 astronomical unit is Earth-Sun distance of 150 million kilometers. Their orbital period is 50 years. And the age of the system is 230 to 240 million years. And right now they are approaching the Sun at a speed of 5.5 kilometers per second. This is a very interesting diagram of the distances of the stars to the Sun versus time. Here is now. So this is a time scale from 20,000 years in the past to 80,000 years into the future. Right now the closest stars are the stars of the system Alpha Centauri and the star Proxima Centauri. And you can see the stars drift towards the Sun and then they drift away. The big star Sirius A and Sirius B are here. So they will stay at about 8 light years distance and then eventually drift away. Yeah. There's another nearby star at 25 light years distance, another A star, that's Vega, also called Alpha Lyrae. It has a 2.1 times the Sun's mass, 40 times the Sun's luminosity. Its age is 455 million years. But its main sequence lifetime is 1 billion years. So its age is 1/10 of the Sun, and its main sequence lifetime is also 1/10 of the Sun. And Vega is known for its high rotation velocity of 236 kilometers per second at the equator. That gives it a very short rotation period of 12.5 hours. The Sun's rotation period is 27 days. This causes a flattening of this big star, and one of the poles of this star is directed towards Earth. There's another system, Upsilon Andromedæ A binary system. It consists of a F star at 44 light years distance. It has a mass of 1.3 solar masses, luminosity 3.6 times that of the Sun. Its age is 3 billion years. It has a hot Jupiter at 0.06 AU, Upsilon Andromedæ B. and there's a red dwarf in the system at 750 AU. Yeah. This is a comparison of the planetary system of Upsilon Andromedae with the solar system. You can see here the hot Jupiter, this B, and the other two planets C and D have a high eccentricity. That's a big difference to the solar system, and they are not in the same plane, C and D. So inner planet is 1.7 Jupiter masses, 4.6 days orbital period. Planet C is the most probably the most massive, with 9 to 16 Jupiter masses. If it's more than 13 Jupiter masses, it could be a brown dwarf. Its orbital period is 241 days. And the outer planet Upsilon Andromeda D has 10 times Jupiter's mass, with an orbital period of 1,276 days. This is another very interesting system, was very important in the history of the exoplanets. That's HR 8799, A-type star at 133 light years, again 1.4 times the Sun's mass, about 5 times the Sun's luminosity. Its age is 30 million years. It was discovered by direct imaging. And this big star has 4 big super-Jupiters with 6 to 9 Jupiter masses. They orbit at 16 to 72 AU distance. Orbital periods are between 45 to 460 years. So this reminds you of to the solar system. It's a bigger version of the solar system with 4 super-Jupiter planets. And there's a thick dust disk at 2000 AU distance. It is massive enough that it could make this entire system unstable. This is an artist's image of one of the planets, HR 8799e, at 16 AU. With 7 Jupiter masses. Its orbital period is 45 years. Methane and carbon monoxide were detected in the atmosphere. Its surface temperature is 1000 Kelvin because the system is still very young. And the question is, what kind of exomoons could such a planet have? Theoretically, it should have moons that are more massive than all the moons in the solar system. There's another star, HD 33564, F star at 68 light years. It has 1.3 times the Sun's mass and 3.4 times its luminosity. Its age is 1.8 billion years. This star could be a member of the Ursa Major moving group. This is a group of over 150 stars with a common origin, moving with similar velocities at 14 kilometers per second, and they move in the same direction. This is a planet, interesting planet of the star HD 33564b. It is at 1.1 AU distance, it's in the habitable zone. It has more than 9 times the mass of Jupiter. And one other difference to Jupiter is its high eccentricity of 34%. Jupiter's is just 5%. And the orbital period is 388 days of this planet. And theoretically, this planet is so massive that it could have Mars-sized habitable moons. There's another interesting star, HD 100546. This is an image from Hubble Space Telescope. This is an example for a B-type star at 353 light years distance. It has 2.2 times the mass of the Sun and 20 times its luminosity. The age is 5 million years. This type of star is called a Herbig AEBE star. It's a pre-main sequence star, so this is a star that has not started the hydrogen fusion yet. This orange dot is the location of a protoplanet, and this star could have also two Jupiter-type exoplanets. This is a computer render of how this B-type star HD 100546 could look like, and in this system there were also 2 circumstellar disks detected. This is another interesting star, that's Zeta Ophiuchi. This is an image from the Spitzer Space Telescope. This is an example of an O-type star at 366 light years distance. It is 20 times the mass of the Sun and over 74,000 times its luminosity. The age of this star is just 3 million years. This is a member of the Scorpio-Centaurus Association of Stars. Its velocity is very high at 30 kilometers per second. And in this image you can see the bow shock from the interstellar dust cloud. This is the Quintuplet cluster, a beautiful image from the Hubble Space Telescope. This is a cluster of massive young stars that are just 100 light years away from the galactic center at 26,000 light years distance. The total mass of this cluster is 10,000 solar masses, and its age is about 5 million years. And this is one of the big stars in this quintuplet cluster. Is another Hubble image of the Pistol star. This is a blue hypergiant star with 125 solar masses and 3.3 million times the luminosity of the Sun. Its size is 420 times that of the Sun, and its age is 4 million years. And this star has already lost about 10 solar masses in a time period from 4,000 to 6,000 years ago to outbursts that produced this nebula. And the future of this star is not clear. This is an animation of the supernova SN 1979C. It shows you the formation of the stellar mass black hole. And this is a potential future of the Pistol star in 1 to 3 million years. And it seems a violent and destructive event, but some of the material gets distributed in space, and this is the material for future generations of stars. This is a nice comparison. At the right you can see the Sun, tiny. The Sun is much bigger than the big majority of the stars, which are the red dwarfs, but compared to the Pistol star, it's just a tiny star. That shows you how big this Pistol star is. And that was today's astronomy video. You can check out my other videos from the series about astronomical objects, and you can check out the links in the description field of the scientific articles. The first article is interesting because it's an introduction to astronomy. Thank you for watching. Have a nice day. Bye bye.